Hello everyone, welcome to this session on the computer aided manufacturing, the CAM, which we are going to be doing it with the help of SolidWorks. And the add-on in the SolidWorks is the SolidWorks CAM, is what we will be using for understanding the computer aided manufacturing or the machining part of this course. So the topics that we are going to be looking at this week are getting started with the SolidWorks CAM, the introduction and some of the key terms that we will be looking at. Then we will go over the numerical control part programming, where we will look at the G codes and the M codes for the CNC machines. How do we generate these codes and try to understand the terminology and the nomenclature for the NC part programming, and then we will look at the SolidWorks CAM NC editor. Okay, so we're going to get started with the introduction of the SolidWorks, and then we will continue with the other topics. All right, so to introduce this topic on the SolidWorks CAM, the SolidWorks CAM is basically provided by CAMWorks, and you can find more information on the CAMWorks by visiting the www.camworks.com. The SolidWorks CAM is basically a parametric feature-based virtual machining software that can integrate the design and the manufacturing in one application. By defining the areas to be machined as machinable features, what SolidWorks CAM can do is it can apply more automation and intelligence into the CNC toolpath creation. Okay, and then this approach is very intuitive, and it follows the feature-based modeling concepts of what we have learned in the CAD design process. And in addition, also the toolpaths which are generated are associated with SolidWorks parametric solid model. And what that means is, if the solid model is changed, the toolpaths are also changed automatically with very minimum user intervention. Okay, and the one of the unique feature of the SolidWorks CAM is something that is called as AFR, which is the automatic feature recognition. So it can recognize features, for example, the holes, pockets, slots, the chamfers and ribs, and all other features, standard features, which can be recognized. And so accordingly, the SolidWorks CAM can generate the toolpath or choose the appropriate kind of machining tools in order to create or fabricate those features. So instead of just using the extrude cut all the time, if you know that is a standard feature, you can always make sure that to use the standard features such as hole wizard, so that since the hole wizard is a standard feature, the CAM can automatically recognize it using this AFR, and then it can use the appropriate tool for it. And same thing, for example, with chamfer. So if it's a standard feature, you can make sure that you use the chamfer feature rather than again extrude cut. So as many standard features as you can use from SolidWorks, that is always recommended, so that can easily be integrated with the design. All right, and then another powerful capability of SolidWorks CAM is called as TechDBM. So it's basically a technology database. That's the TechDB, and that's the trademark. So it provides the ability to store machining strategies feature by feature, and then reuse these strategies to facilitate the toolpath generation. Okay. It also maintains the information regarding the cutting tools which are available on the shop floor, and the this database within the SolidWorks CAM can also be customized to meet the the users and the shop floor's requirements. So something that you can also customize that, and then basically that helps in storing the best practices at a centralized location in support of the machining operations, both in computers and on the shop floors. All right, so that's the TechDB and also the AFR, which are the unique features of the SolidWorks CAM. And as we go on, using this SolidWorks CAM software, we'll get to know more about these different features. All right, so now let's take a look at what is the virtual machining. So the virtual machining is a simulation-based technology that supports engineers in defining, simulating, and visualizing machining operations in a computer environment using CAM, or the computer-aided manufacturing tools such as the SolidWorks CAM. And once the machining simulation is finalized, the tool paths that is created by this software, you can easily convert them into G codes, and then you can upload them onto the CNC machine on the shop floor, so you can physically machine the parts. Okay. The operation plan also involves the NC operations to be performed on the stock. Stock is basically the starting material that you can select with in order to machine into the features that you want to create on it, and including part setup origin, where the G code program 0 is located. Okay. Also included is choosing the cutting tools, or how do you define the machine parameters, such as how much should be the feed rate, what should be the depth of cut, and all that. And you can also note that the operation plans can also automatically be generated by the technology database of the SolidWorks CAM. Okay. And so that's basically, in short, what the virtual machining environment is all about. Working in a virtual environment usually offers many advantages in making adjustments. You can detect the errors. You can also correct those mistakes before you are taking it for the production, and also you can understand the machining operations through the visualization of machining simulation. All right, so these are really great advantages of what the virtual machining process. And the important steps in the virtual machining, you can take a look at it here. You start off obviously with creating a design model, and so basically you're creating a solid model, either a part or assembly in SolidWorks, and then you're choosing a NC machine. It could be either mill or lathe, which is intended for machining operations. You can choose a tool crib, you can select a post processor, and select the coordinate system. In this step, you're creating a stock. What are its size and dimensions of that. The starting material. What is the material type, of course. All those things can be decided at this stage. Then you can use the AFR, or the automatic feature recognition, to extract the machinable features which are embedded in the solid model. For example, holes, pockets, bosses, and all that. Or you can manually create machinable features also at this particular stage. Okay. Then you're gonna generate the machining operation plans, including the specific machining strategies, cutting tools, and machining parameters. For example, feed rate, the spindle speed, or the step over, or the depth of cut, and so on. All right. After that, you're going to generate the tool path, and then once you generate the tool path, how the tool is going to move, what kind of tool is going to be used in what step, and basically the tool will be moved in with reference to a particular coordinate system, obviously in X, Y, and Z directions. And then you can simulate the tool path. That's basically a advantage of doing a virtual machining process, where you can actually simulate the tool path to exactly get a good idea about how the machining is going to take place. And then in the post process, you can convert these tool paths into a G code, and then verify these G codes so that then you can actually transfer these into the CNC machines, and then you can manufacture the product. All right. So these are basically all the virtual machining steps. Okay, so let's take a look at the machining modules now. So SolidWorks CAM basically support 2.5 axis and milling and 2-axis turning. So what is this 2.5 axis milling, or what's the difference between the 2.5 axis against the three axis milling, for example? So what 2.5 axis mill means is that first of all, an axis is the direction of motion controlled by the CNC machining control. So it can be linear, along a straight line, or circular for a rotary motion. And the number of axes a machine has determines its machining capabilities. So a 2.5 axis machine really has 3 moving axes, but only 2 axes can move together. For example, all the, let's say a tool, let's say it's doing a drilling, it can move simultaneously in 2 axes, let's say X and Y, okay, like in a plane. And it can move in the Z direction, downward or upward, but at that time the X and Y axis are not moving, so only Z axis is being moved independently of X and Y. So at a time only 2 axes can move together, like an XY axis. So that is why the machine is a 2.5 axis machine. Okay, and in the 3 axis machine, it has 3 linear axes, which means the tool can be moved in 3 axes simultaneously. And similarly, then a 4 and a 5 axis machine will have 3 linear axes as well as 1 or the 2 rotary axes. Okay, so you can note that 2.5 versus 3 axis has yet another context. So 2.5 axis machining requires that the machine have 3 axes, but only 2 axes can move simultaneously at one time. So that means simple operations like drilling and most milling operations fall in this category. Okay, and like I said before, in the X and the Y axis, a tool can move, for example, in a circular arc direction on a plane. That's basically moving X and Y together. So at a time only 2 axes can be moved, and so that is why it is the 2.5 axis, although it has 3 axes for the Z direction. And on the other hand, 3 axis machining requires that all the 3 axes can be moved at the same time. So that involves a little bit more complex operations like machining of sculptured surfaces, which are required in molds and airfoils. Those basically fall in this category. Okay, so the SolidWorks CAM, coming back to the machining modules, it has a 2.5 or a 2.5 axis mill, and that includes roughing, finishing, thread milling, face milling, and single point cycles. For example, drilling, boring, reaming, tapping, to machine prismatic features. And I'm sure you've done all these things in your manufacturing processes class, as well as 2-axis turning is something that SolidWorks CAM can do, and that includes roughing, finishing, grooving, threading or cutoff, and single point cycles. For example, drilling, boring, reaming, and tapping. Okay, so the SolidWorks CAM Professional, in addition to the tolerance-based machining, which is called as a TBM, also supports some of the additional features such as high-speed machining, HSM that is called, or the configurations, or the assembly machining, or turning, and all that. Okay, so now let's take a look at the interface, the user interface of SolidWorks CAM. And let's take a look at this user interface in our next video.